Let's have a look at version 3 of Tesla's solar glass roof. We're going to talk very briefly about how solar works and some of the changes and enhancements starting with version 1 and version 2 and going to version 3 of the solar roof and where Tesla sees production going forward. But first, please subscribe to our YouTube channel. We would really appreciate your support in helping us grow our channel, and leave any comments or questions you may have in the section below. In August of 2016, Elon Musk unveiled the solar roof, a new type of roof with the solar panels built into the shingle tiles. It would be used to generate power for the home and at the same time look beautiful for passers-by in the neighborhood. The solar roof could be combined with a Tesla Powerwall, which is a residential-sized battery to store the energy generated by the solar power and later be used at night or during peak usage hours, which in many areas have greater electricity prices when using power from the grid. In theory, the right amount of solar power from the solar roof and enough battery storage systems could take a house completely off the grid and make it self-sustaining. However, the solar roof ran into setbacks with high cost and slow installation time, which never allowed it to reach the mass market. It was only installed on a very limited number of houses. Even Elon Musk has version 1 of the solar roof on his own house. Actually, Tesla wasn't even the first company to attempt to build a solar roof. Dow Chemical Company, the American chemical and industrial company, developed a solar roof called the Powerhouse. However, they discontinued their solar shingles lineup in 2016 as it wasn't working out for them economically. Clearly, building a solar roof was no easy feat, and a company called RGS Energy bought the licensing from Dow but still hasn't ramped up a solution for the mass market. Tesla's version 1 and version 2 of the solar roof ran into similar problems of high cost and low installability. Only at the end of 2019 is Tesla's version 3 promising to be the first mass-produced solution to deliver decentralized power generation to tens of millions of houses and bringing forth a sustainable future. Of course, 430 quintillion joules of energy hit the Earth every hour, which is enough to power the world for an entire year. Yet we currently aren't harnessing this energy and turning it into something useful. It makes sense to have a product that makes roofing come to life to collect this power, and Tesla is working hard to achieve this. Let's have a brief look at solar panels. At a simple level, a solar panel is made up of various layers of silicon, usually made from a single crystal. The layers go through a process called doping, in which another material is combined with the silicon to make it more positive or more negative. For example, the element phosphorus may be used to dope silicon to make it more negative by adding electrons as seen in the top portion of this diagram. The bottom layer gets boron, which makes it more positive by adding these fixed holes or the absence of electrons. This structure also has the property or a phenomenon that occurs where some of the electrons near the center or the junction diffuse over to the positive side, leaving holes in their place. This creates an electric field, and this region is known as the depletion or junction region and acts as an insulator so that no electrons can pass through or hop over to the other side. When the sun shines on the solar panel, the energy from the photons of light bump into electrons and free them from the silicon. Since the junction region in the center gap prevents electrons from jumping right over, there are metal plates on the sides of the solar panels that collect the free electrons and allow them to flow through the wires from the negative to the positive side, creating an electric current, thus converting sunlight into electricity. Now, just to get slightly more technical and into quantum mechanics, the energy of the photon of light from the sun needs to be higher than what's called the band gap to excite the electron to the next energy level and to free that electron. The band gap is the amount of energy required to bump the electron into the conduction band, and this amount of energy is different for different materials. An example of a material with what's called a direct band gap is gallium arsenide, GaAs, which is very good at absorbing light. You only need a very thin film of gallium arsenide to be very efficient as a solar panel. However, there are also materials with indirect band gaps which require energy from a photon and also additional momentum from heat energy or a heat particle called a phonon in order to knock out that electron. Silicon is actually an indirect band gap material, which means it actually isn't so great at absorbing light, so a much thicker piece of silicon is required. There are also materials that can be engineered to have direct band gaps, which is more favorable. But gallium arsenide solar cells, for instance, are better for more expensive projects such as solar cells for satellites, where the budget is higher than a residential house. They are also good at protecting themselves against radioactive damage, as it actually has a higher band gap, but it's a direct material. And gallium arsenide solar panels hold the world record for being the most efficient at 29.1% efficiency for a single junction solar cell like we've seen. The theoretical limit is about 33%, meaning at how good it is at converting light into electricity. Now there are other configurations for solar panels that have stacked layers with theoretical limits for absorbing sunlight closer to 68.7%. However, these require more materials for each layer and are more expensive, and we still have not really gotten close to this theoretical limit. The crystalline form of silicon used for making solar cells is more commonplace despite their inefficiencies in band gaps. It's only about 15 to 20% efficient at converting light into electricity. But for one thing, silicon is very abundant and cheap to manufacture. Compare this to gallium arsenide, which is much more expensive. Also, because a thicker layer of silicon is required, it's more robust and easier to handle as compared to an equivalent thin film of gallium arsenide. There are also relatively few impurities in silicon as compared to other materials. So let's switch gears back to see how Tesla will be playing a role in this. Tesla will be manufacturing the solar cells required for the solar roof at their so-called forgotten Gigafactory 2 plant in Buffalo, New York. This factory actually came about from the Solar City acquisition and hasn't gotten much attention since Tesla's other Gigafactory 1 in Nevada focuses on mass-producing car batteries, and the new Shanghai Giga 3 will be pumping out full electric vehicles. The Buffalo Gigafactory 2, however, has been making all Tesla superchargers, inverters, power packs, and the electronics for Tesla's Megapack battery solutions. But all of these things so far have been a much smaller portion of the company than the vehicle business. However, Tesla CEO Elon Musk believes that the solar and battery business could in the future be larger than the vehicle business, and Gigafactory 2 will play a major role in getting there, starting with the solar glass roof, or version 3 of the solar roof. The first version of the solar roof tiles were meant to look like a regular roof when viewed from a passerby on the ground. However, when viewed from the top, the solar cell could be seen through the tile, which would be perfect for absorbing the sun's rays. But in the first few versions of the product, Tesla noticed that the cells would look different colors from different angles. For example, green from one angle and purple from another angle. So in the third version, V3, the tiles have been changed to be more isotropic, meaning they look the same from any viewing angle. The previous versions of the solar roof were also much more expensive, inhibiting the mass market to adopt the technology. Tesla now hopes to achieve a cost below the cost of a regular roof plus solar retrofit with its new version 3 roof. Therefore, this roof is best for brand new homes and for those looking for a roof replacement. Furthermore, Tesla originally announced 4 different roof types. However, they have scaled back and are focusing on the textured black glass tiles shown here in the bottom left. Other versions are expected to come out every 6 to 9 months after the textured glass hits volume production. The biggest challenge, however, is speeding up the slow installation time, which is a major reason solar roof hasn't been adopted. Versions 1 and 2 were very complicated and would take much longer than a single day for installation. Many consumers don't want to live in a home with no roof or with half a roof. Also, a large part of the installation process involves cutting tiles and basically building and manufacturing the roof while it's being installed, so this doesn't make a lot of sense. Instead, version 3 offers many new solutions in order to improve on this, and Tesla expects to continue improving going forward. One change they made was that the V3 solar glass roof tiles will be larger and have increased power density. They contain a reduced set of parts and half as many sub-assemblies as previous versions of the tiles, making it easier to manufacture and lowering the cost. They also changed up some of the materials and used new technology to make the hidden solar cells more scalable. Previously, installers had to cut tiles and needed tools to do that, which was very cumbersome. With the new solar roof, that's no longer required. That's because a lot of the production was done at the house, but now it will be done at the factory where it should be. Also, because the solar cells are partially hidden, there is a further 10% reduction in efficiency for these cells. However, as compared to solar panels on top of a regular roof, there can be many more cells in the solar glass roof to make up for this inefficiency, since the solar glass roof covers literally the entire roof and not just a portion of it. In terms of logistics and installation, Tesla will be enhancing how parts get from the factory to the roof and how they come together. In previous versions, the edges or trim of the roof was like custom handicraft, Tesla said. But now they have beautiful solutions that are more achievable in the field and simpler to install, with the goal being to install it faster than a regular roof or in less than 8 hours with a small team of installers. Tesla even has internal competitions with 2 teams in 2 identical houses to see who can install the solar glass roof the fastest, and it learns from these tests with a rapid feedback loop to the engineering and manufacturing teams. And in the near future, it will allow licenses to third-party installers to install these types of roofs. The V3 version of the tile is 3 times stronger than standard roof tiles, and they offer a 25-year warranty. Elon originally wanted an infinite warranty, saying that the roof would outlast the actual house. But this 25-year warranty is more realistic, since they found it difficult to do an infinite year wear and tear test. But the strengthened glass will easily outlast a regular roof. It will probably be on par with a metal roof plus the benefit of solar. And it also has a 1.75-inch rating for golf ball-sized hail, which can happen infrequently, but if it does, will greatly damage a regular roof. The price for the third version of the solar roof has come down about 40% from the previous version, and is starting to get closer in price to other types of roofs. But clearly now it's more affordable than a regular roof plus separate solar panels. With incentives including not having to pay to power your home, the $7 per square foot price will be appealing to residential consumers. Tesla Solar Glass Roof V3 is currently available, and the company aims to ramp to 1,000 units per week in just a few months from its announcement date. Elon Musk has said that the total addressable market for this is 100 million houses in North America, and so he isn't worried about demand. With a 25-year replacement cycle, that's 4 million roofs per year, plus the 1 million new ones which are built each year. While Tesla doesn't really have any competition for this product, I don't think they will be able to service 100% of the market. But that said, each solar glass roof sale may give Tesla revenue similar to about 80% of a Model 3 sale, let's say. Thus, delivering about 50,000 roofs could be equivalent to delivering 40,000 vehicles, which will be a big needle mover for Tesla's overall business. So Tesla believes they now have a product that is ready for prime time. The solar roof has many advancements over its predecessors that's allowing Tesla to ramp up volume production for the first time and release a more affordable solar roof to the mass market. Just another step in the Tesla playbook for making the world run on sustainable energy. Well, I hope you enjoyed this video. Please subscribe. We would really appreciate your support in helping us grow our channel. And let me know if you have any questions or comments below. Thanks so much for watching.